All right, let's dive in. Today, we're going to pull back the curtain on a piece of tech that's so fundamental, so deep in the bones of our modern world, you probably use it 100 times a day and don't even realize it. We're talking about the C programming language.
So think about this for a second. What's the invisible thread that connects your smartphone, the complex electronics inside your car, and even the robotic explorers roaming around on Mars? The answer is C. It's like the ghost in the machine. It is the absolute bedrock of our digital world. To really get how this all happened, we're going to walk through its story in 4 main parts. We'll start by looking at what the world was like before C. Then we'll see its revolutionary birth, watch how it went from total chaos to a global standard, and finally, we'll unpack its incredible long-lasting legacy.
Okay, so let's set the scene. It's the late 1960s. We're in the era of massive mainframe computers, and the whole industry is wrestling with a really big problem: portability. Over at the legendary Bell Labs, researchers were pulling out of this huge project called Multics. It was super ambitious, but honestly, it was a beast, way too complex and crazy expensive. So a small team, including guys named Ken Thompson and Dennis Ritchie, decided to build something new, something lighter and way more efficient. They called it UNIX, and this new OS needed a new kind of programming language to go with it. Ken Thompson's first crack at it was a language he called B. It was a step in the right direction for sure, but it had one massive flaw. It was typeless. Now, what does that even mean? Well, think of it this way. B could only see one size of thing, the native word of whatever machine it was on. It had no way to tell the difference between, say, a tiny single character and a great big number. And as you can imagine, that became a huge roadblock as new, different kinds of computers started showing up. And that exact limitation, that one big problem, is what set the stage for one of the most important breakthroughs in the entire history of computing. The solution was clear, at least in theory. The next language had to be smarter. It needed to get that data comes in all different shapes and sizes. It needed the concept of types. And this is where Dennis Ritchie really becomes the hero of our story. He took the B language and gave it exactly that superpower. And what's so amazing is how simple but just profound this was. He just introduced these basic data types: char for single characters, int for whole numbers, and float for numbers with decimal points. With that one change, he created a brand new, way more powerful language, and, in a nice little nod to its predecessor, he called it C. This all leads us to a really pivotal year in computing history, 1973. This is the moment C went from just being a cool new language to being the key that would unlock the entire future of software. So in 1973, the team rewrote the very core of UNIX, the kernel, in C. Now, this was absolutely unheard of. Before C, operating systems were basically shackled to the specific computer hardware they were built for. But by using a high-level language like C, UNIX was suddenly portable. You could take the same operating system, and with a little work, get it running on a totally different machine. C didn't just build a program, it literally freed the entire idea of an operating system from its physical prison. This newfound freedom, as you can guess, made C explode in popularity, but that very success created a whole new set of problems. As C started spreading like wildfire through universities and companies, everybody started building their own compilers for it. And of course, everyone added their own little tweaks and features. The language was starting to splinter into dozens of slightly different, incompatible versions. It was becoming total chaos. So how did they fix this mess? Well, it happened in a few stages. First, in 1978, Brian Kernighan and Dennis Ritchie wrote the book on C. Everyone just called it KNR-C, and it became the unofficial rulebook. But we needed something more formal. That finally happened in 1989 with the ANSI C standard, also known as C89, which really unified the language once and for all. And C didn't just stop there. It kept evolving. In '99, C99 gave us features we totally take for granted now, like those simple double-slash comments. And then in 2011, C11 added crucial support for modern multi-core processors. And that brings us to the final part of our story, C's incredible legacy, and why a language that's almost 50 years old is still one of the most important pieces of technology on the planet. You know, people often call C the mother of all languages, and that is not an exaggeration. Its DNA is absolutely everywhere in the software that runs our lives.
Just look at this breakdown. It gives you a real sense of its massive influence. It's not just one thing. C has direct descendants, it influenced the whole syntax, the look and feel of countless other languages, and it's the language that was used to build the core engines and operating systems that power the modern world. Let me make this really concrete for you. C++ literally started its life as a project called C with classes. The syntax of huge languages like Java and C#, it'll feel instantly familiar if you know C. Even Python, which seems totally different, has its main interpreter, CPython, written in C for raw performance. And here's the kicker. The kernels, the absolute hearts of Windows, macOS, and Linux, are all written predominantly in C. So what's the big takeaway here? C's story is just incredible. It started out as a really practical solution to a very specific problem: how to make a new operating system portable. And from that humble, practical beginning, it grew into the invisible, load-bearing backbone of pretty much all modern technology. And that leaves us with a really fascinating question for the future, right? For half a century, we've been building this incredible digital civilization on top of C's powerful, efficient, but yeah, aging foundation. As we push forward, will we just keep building on it, or will new languages and new ideas finally emerge to replace the language that built our world? Definitely something to think about. Thanks for joining this explainer.